let's imagine that the ocean represents all knowledge of physics, okay? Now imagine you go down the beach and that water comes up over your ankles and quickly goes back away again. That experience can be uncomfortable, cold, and not pleasant. That's how many students think of physics, okay? Now, I think one of the reasons that they think of this is because they're exposed to this limited branch of classical physics that has limits. Now, you can decide to make the ocean a part of your life. You can visit it, swim in it, or you can choose to never go in it again. And that's what people do with physics. They either make it a part of their life, they make it their profession, they make it a hobby, or they run screaming from it, okay? Which I'm sure some of you have done. Now, I truly believe that part of this is because they were exposed to that limited branch and they didn't see the mystery and beauty that's really modern physics. They were exposed to a model with limits. So why do we teach with limits? Why do we teach these models if they inherently have limits? Well, this is how all science is taught. All science ends up having scientists make observations, create a model, and then those models are used to make predictions down the line. Well, some of these models work and some of them don't, okay? Spontaneous generation, you've all heard of that. Matter coming from other types of matter, thrown out. The model doesn't work. It'll explain why some matter comes from other matter, but it's not right, okay? Neither is the plum pudding model of the atom, okay? There's no nucleus. It'll explain that positive and negative, but it won't explain other things. Again, the model's thrown out. Ptolemy's orbits will explain and predict where planets are supposed to be, but it's not right. It has limits, okay? So why are these models talked about in high school classrooms and then quickly dismissed while there's other models that have limits that we continue to use, okay? And that model really is Newton's laws. Newton's laws are great, but they have limits. When you have mass that's going close to the speed of light, Newton's laws break down. Newton's laws don't explain why gravity can bend light. It has limits. So why do we stop there? Why isn't modern physics a greater part of the high school curriculum? Okay, so the real question is, why are we teaching with limits when we're constantly pushing our students to try to push their limits, when we're ourselves trying to push our limits? Well, the answer really lies in what teachers kind of have to do. And teachers have to teach to standards, and they teach to a test, okay? They want their students to do well. And if you take a look at the SAT-2 in physics, and take a look at those percentages, how much is focused on Newton's laws and classical physics, and how much is focused on modern physics? There's a big disparity between those two columns. And that's why when you're in that high school classroom, you're spending a lot of time on those classical laws, okay? If you think about the next generation science standards, these were supposed to reframe how we taught science K through 12. But those standards don't even mention Einstein. Those standards end up talking a little bit about our new technology and don't focus on anything that has to do with modern physics, okay? So even with your limited nature of modern physics, which one of these men do you recognize? My guess is the one on the right, okay? That's Einstein, the father of modern physics, not Newton, who's on the left, the father of classical physics. Visually, Einstein is the one you go to. He's the one you recognize with that crazy white hair, not Newton over there with, you know, really no distinguishable features. Let's be honest, okay? So now, the problem is visually, yes, that's Einstein. But if I were to ask any of you and say, do you remember this? For every action, there's an equal and opposite reaction. You're gonna go, oh yeah, I kind of remember that. But if I were to say, space and time are really two different dimensions, and how you observe them depends upon your reference frame, you would say, what? Okay, because those were Einstein's words. They're not mentioned in a high school class Instead, we focus on Newton's laws, okay? Now, there's many people that say, this is not relevant to a high school student's life, okay? They're not gonna see this. They're not gonna be dealing with mass, traveling close to the speed of light. It's irrelevant to them, but it's not, okay? If you think about how many times you've used your GPS in the last month, I'm sure it's more than once. Well, GPS, that works on the basis of general relativity, okay? And if you've ever tried to teach a high school student how to use an old school compass, you will see how much they need their GPS to get from one place to another. Now, if you've plugged something into an outlet, okay, you've used the concept of magnetism. Well, magnetism is explained via special relativity. So these students end up focusing on a box going down an inclined plane and getting the velocity at the bottom, which useful information, but it's not a part of their lives, okay? When you think about the way that we could be utilizing modern physics in the classroom and making them look deeper into what they're using, you would see these concepts come into play much more often than not, okay? So if we were to do this, would we be the first? Would US schools be the first to actually start bringing in and making modern physics a greater part of the classroom? No, okay? The Program for International Student Assessment gave a test on science literacy in 2015, okay? Well, the countries that did better than us, Scotland, South Korea, Norway, they have modern physics as a part of their curriculum. Now, that's not because that content was necessarily on the test, but it's because of that limitless nature that the students are being exposed to in the classroom. It changes things. It changes how students think. They start looking outside of the limits. Now, my question is, does that mean we throw out Newton's laws? Of course not. Okay, Newton's laws work. They are practical. People use them every day. They're not like spontaneous generation that doesn't work, but their simplicity will give you a sense of knowledge, but it doesn't give you a sense of inspiration. It doesn't make you try to look beyond the bounds. It doesn't make you push the limits. That's what modern physics can actually do. When you think about the things that modern physicists are doing right now, it blows your mind, okay? There are scientists that are trying to have matter that go faster, or measure matter going faster than the speed of light, which is thought to be the ultimate speed limit. They think that to try to find the four fundamental forces and to have a theory that explains that, one theory that explains all of them, they think that they can find that out, but it's going to be on a scale 1/billionth the size of what the Large Hadron Collider can actually measure. So they're trying to come up with these theories, and they can't even measure them. So they're only limited by what they can imagine. And you might be thinking, well, couldn't they just make up anything? Well, sometimes if you heard some of those modern theories, you may think, did they just make that up? When you start hearing about things like string theory and multiverses, we can't test that stuff, but that doesn't stop those theories from arising. So you might be going, well, that doesn't really make sense. How are they coming up with theories that they know they can't test? Well, this isn't the first time that's happened. When Einstein wrote his theory on general relativity, he did that in 1915. It wasn't proven until 4 years later during a total solar eclipse. He didn't have the data to prove it, but it was his theory, and it ended up being correct. When you're thinking about modern physics, what you need to be thinking about is, what could my mind possibly imagine? Because that's really what's out there right now. Now, wherever you go in life, okay, whether it be science, whether it be math, or whether it even be the humanities, modern physics can actually help you understanding that, embracing that limitless nature of what modern physicists have to think about in solving their problems can help you say, wow, if they're doing it, let me try to come up with something that pushes those boundaries. Every day we wake up, there's a new app, there's a new gadget, there's a new technology, ones that were never even thought about 10 years ago. So when you go into your fields, when you go out into the world, Try to take that knowledge with you, that people are trying to come up with answers to questions that they have no way to prove, but that doesn't stop them. They don't let anything get in their way. And that's my message to you. Don't let anything get in your way, no matter how outlandish it may seem. Thank you.